Welcome back. Some of you guys don't work visually. You guys work more algebraically. So I'm going to throw an algebraic way to find slope up next. So let me just erase this. So there's an equation for slope. The slope equation is, well, m is your letter for slope. M is your letter for slope. And slope is, let me zoom in. Slope is y2. Oh, I gotta write my basis. y2 minus y1 over x2 minus x1. All that is saying is you take your two y components and you find the difference. That's what we were doing before, right? We were saying, hey, how far is 7 from 4? How far is 12 from 8, right? We're just trying to find the difference of your y's over your difference of your x's. So if they gave me, if I took 2 points, if I get 2 points, and let's just do what we just did before. We did, let's find the exact one we did before. 8, 9, and 12, 4. Perfect, right? If we take those, now all we gotta do is take that information and plug it into the equation. So what I'm gonna do is I'm gonna label my points. These are my x's. This is I'm gonna call this my x2, because it's my bottom x. Sure, it doesn't really matter. And this will be my x1. This is gonna be my y1. This is gonna be my y2. It doesn't really matter the order in which you number them, just as long as you're consistent. As long as 1 point is your x and y of your first point, and 1 point is your x and y of your second point. So what I'm gonna do is I'm gonna rewrite my equation. Now, notice how I'm using the same black framework, but I'm gonna plug in the new stuff. So no matter what, my black framework's always gonna be the same. M equals, it's a division problem between two differences, yeah? Now, on my top, I'm gonna write my y's. So what's my y2? My y2 is 4. My y1 is 9. And then I go to my denominator. My x2 is 12. My x1 is 8. And now all I do is I gotta solve this. All I gotta do is solve this. What is 4 minus 9? Obviously it's getting smaller, so it'll be -5. And then what is 12 minus 8? 12 minus 8 is 4. If we check our answer before from the first video I did in the intro, that was the exact same answer, but we just did it algebraically. We did it using an equation and numbers. Now why don't we do the same thing for the next problem, what we just did for the last one. So I'm gonna leave this up here. All I'm gonna do is we've already did this, so I'm gonna cross it out because we already used it. Okay, and let's do another. So I'm gonna leave my framework. And the equation, the points I used last time was, let's see. Yeah, this should work out, yeah? Let's actually move that over. Oh, not all that, just this. Perfect, just so it's out of the way. So last time, my y's were 12 and 9. And my x's were 0 and -4. Now let's do the same thing. In my denominator, I'm gonna write my x's, -4, 0. And in my numerator, I'm gonna write my y's, -9, 12. Well, looks like we're losing. 9 minus 12 is gonna be -3, because the bigger number is negative. -4 minus 0, if you subtract 0 from anything, if you had 4 cookies and you lose 0, you still got 4 cookies, so we just leave it be. And just like last time, we have -3 over -4. And those negatives cancel, right? Because if they both have a negative, they're really just both positive. And your slope is 3 over 4. Nice and simple. Now, choosing which point is your first point and your second point really doesn't matter. And I'll show you that on my next example. On my next example, I'll show you that. So let's take this and let's erase it. If you need your slope equation, I'll put it right back up top. That's the base. Y2, Y1, X2, X1. Now, that's your basis. Now let's pick 2 points. Actually, I want to put that back in the corner. I don't know why I took that out. I'll put that back in this corner. Now, these are the points I'm going to work with. I'm going to work with the points that we had just prior. Marker. And our 2 points were -8, 5. And 4, 11. Now, in my left example, I'm going to leave it be. In my right example, I'm going to switch it. So I'm going to put a little line in the middle, shoop, shoop, shoop. And I'm going to have an example on this side. So in my left example, I'm going to leave it how it is. This is y2. 11 minus 5. 4 minus -8. And we'll talk about that in a second. And then the other example, I'm going to flip them. 5 minus 11. -8. Oh, let's get that in red. -8 minus 4. Now let's talk about them. So we can still solve it like normal. In the numerator, what's 11 minus 5? 11 minus 5 is 6. Over. Now, if we have 4 minus -8, if you ever see a minus negative, I like to turn that into a big, fat plus to show that you're doing the opposite. If you ever have a negative sign, by a minus sign, right by each other, you fix into a big, fat plus. Now we have 4 plus 8, which is 12. So we have 6 over 12, just like we did last time. And then just like last time, we can simplify this. What number goes in both 6 and 12? 6 does, so this is really 1 over 2. Perfect. If we solve it like, if this is your y2, this is your y1. Now let's flip it. Let's do the other example. Same idea. What is 5 minus 11? 5 minus 11 is -6 over. And then we have -4 minus 8. They're both negatives, right? So we can actually just combine them, keep the sign. So 8 plus 4 is 12. The negatives keep together. And now we have -6 over -12. That's not the same as this, is it? But it kind of is. Because what did I say if the top and bottom are both negative? Can't we just make them both positive? And now that's the exact same fraction. And we can bring it down, and we can call this 1 over 2. Same idea, same answer. And now we work with it from there. Okay? Now, as we've gone through these, we've seen positive slopes and negative slopes, right? I'm going to erase this. Right? We've seen slopes like we had one example slope was -5 over 4, right? So that's going to go down to the right. So that slope's going to go, you can see how that goes down to the right? And we have slopes that were positive. We had m equals 1/2, which means it goes up to the right, which means it goes up to the right. Now, there's other types of slope. There's also slopes that go, let me shrink this board. Hope that didn't work. Let me shrink this board. There it is. Now, there's other examples, right? So those are, we're going to have 4 quadrants. Hopefully, you see that yellow on the board? Oh, you kind of can. Right? We're also going to have, so this is positive. This is negative. And then we're also going to have something called zero slope and something called undefined. Boom. So zero slope is, what do you think is going to happen in zero slope? Obviously, you probably have known this already, but zero slope means it doesn't go up or down. The y doesn't change in comparison to the x. So at the end of the day, it's going to be 0 over some type of number. Let's erase that. So why don't I use the example, why don't I do the numbers? What if you have a point at 9, 5, and 7, 5? Those are our 2 numbers, okay? So let me just put it in my equation. Always have that bracket there. This is my x, this is my x, this is my y, this is my y. So in my numerator, I'm going to have 5 minus 5. And my denominator, I'm going to have 9 minus 7. So what does that simplify to? What is 5 minus 5? 0. 9 minus 7 is 2. So x doesn't go up or down. I mean, y doesn't go up or down, but x keeps moving along. So this is what this slope is going to look like this. This is a zero slope line. Perfect? So that's all you got to do. So this slope is 0, which is different than what we're going to talk about next. Next, we have something called undefined. So instead of y not moving, but x moving, what do you think the opposite of that would be? The opposite of that would be undefined. So that would be if I took a point similar to this, but I flipped it around. So that would be if I had points like, -3, let's get that in a different color so you can see it better. So let me get my brackets going. That would be if I had points like, they both have -3 for x, and the y is 5 and 12. Sure. So I'm going to set up my bracket. I'm going to set up my my base. I always have that. We always start with that. And I plug in my numbers. Let's do 5 minus 12. Let's do -3 minus -3. And we simplify this, yeah? What is 5 minus 12? Looks like it's getting smaller, so it'll be -7. Now we have -3 minus -3. Well, if we ever see a negative and a minus right by each other, black minus by red minus, fat plus, -3 plus 3. If you lose 3 and gain 3, you're back at 0. So this is 0. Your denominator is 0. And like you learned probably in elementary school, is you can't divide by 0. It's not allowed. It's undefined. That's the word we use for it now. So your y is moving, but your x isn't. So y goes up and down. X doesn't move at all side to side. So you go up, and we don't move side to side. Just like this one was, you don't move side up, and you only move side to side. They're opposites. So this is called undefined slope if it goes straight up and down. You cannot climb that mountain. This is zero slope. There is no mountain. This is a negative slope. You're going down the mountain. This is positive slope. You're going up the mountain. So there's a little sneak peek into slope, and I hope to see you next video too. All right, bye-bye.